Hello viewers, this is Mahmood. In this video we are going to solve past paper problem, and that is related to second order differential equation. So the problem is find the particular solution of the following second order differential equation. So you can see this is our second order non-homogeneous linear differential equation. And given that y of 0 equal to 14 and y prime at 0 equal 25. Okay, so here we are going to use the method of undetermined coefficients to find the solution, right? So our differential equation is, that is d square y upon dx squared minus 2 dy over dx minus 15y is equal minus 90x squared plus 6x minus 209. Okay, let me call this is my equation number 1. Okay, so the associated homogeneous equation, the associated homogeneous differential equation is that is d square y upon dx squared minus 2 dy over dx minus 15y equal to 0. So here I can take y as a common, so that would become d square over dx squared minus 2 d over dx minus 15 into y equals 0. Okay, so then the auxiliary equation would become the auxiliary equation is that is d square over dx squared minus 2 d over dx minus 15 equal to 0. Okay, so let me denote m is equal d over dx, so then m square would become d square over dx square. Okay, so putting back into the auxiliary equation, so the auxiliary equation will become m squared minus 2 times m and then minus 15 equal to 0. So it's a quadratic equation, so by using a factorization we have to factorize it, so that can be written as m squared minus 5m plus 3m minus 15 equal to 0. So here we can take m as a common from the first two terms, so that would become m into m minus 5, then plus we can take 3 as a common, so that would become m minus 5 equal to 0. Okay, again we can take m minus 5 as a common factor, so that would become m minus 5, and here we have m plus 3 equal to 0. So here you can see by the zero factor property we can write m minus 5 equal to 0 or m plus 3 equal to 0. So here shift this minus 5 to the other side, so you will get the value of m, that is 5. Or in the second, here we have m is equal minus 3. So we got two roots. Okay, so the roots are real, and also they are distinct. Okay, so the uh, complementary function y sub c is, that is y sub c equal c1 e raised to the power the first root, that is 5 times x, and then plus c2 e raised to the power the second root times x. So this is our basically complementary function. Okay, so now we are going to find the particular solution, that is y sub p. Okay, so you can see here the non-homogeneous term, on the right side of the equation number 1 here, that is the non-homogeneous term is, that is a quadratic polynomial. That is minus 90x squared plus 6x minus 209. Okay, so basically the right side of the equation, this is a quadratic polynomial function. So our particular solution, the general particular solution would be our the general form of the quadratic function. So let the particular solution y sub p is, that would become y sub p is equal, and the general form of the quadratic function is a x squared plus bx and plus c. Okay, we are a, b and c are constants, right? So next we are going to find the first derivative of this particular solution and the second derivative as well. Okay, so the first derivative is dy sub p over dx is equal, the derivative of ax square is 2 times ax plus the derivative of the second term is b, and the derivative of c is going to be 0. And the same way we need to find the second order derivative of this particular solution, that is d squared y sub p over dx square, that is going to be, so we are taking again the derivative here, so the derivative of 2ax is going to be just 2a, and the derivative of p is 0. Now we are going to put these derivatives in the equation number 1. Okay, so here so equation number 1 implies that, so d square y upon dx square, so we have to put 2a, so that is 2a, and then minus 2 times the dy over dx is basically 2 times ax plus p, and then minus 15y, so minus 15y is basically ax plus bx plus c, ax squared plus bx plus c equal to the right side, that is minus 90 x squared plus 6x and then minus 209. Is it okay? So now we are going to simplify this. So here 2a minus, we have to multiply 2 inside here, so that is minus 4ax, then minus 2b is then minus, we have to multiply 15 inside, so that is minus 15ax squared and minus 15bx and then minus 15c is equal minus 90x squared plus 6x and minus 209. Okay, so on the left side we have the highest power term is x squared, so that is minus 15ax squared, and then here you can see we can take x as a common here, so that would become just plus minus 4a and minus 15b. We can take x as a common factor, and then we left with the constant, that is plus 2a and then minus 2b and then minus 15c is equal minus 90x squared plus 6x minus 209. Got it? So now we have to compare the coefficients to get the values of a, b and c. Okay, now comparing the coefficients. So now you can see the coefficient of x square is that is negative 15a, and here the coefficient of x square is negative 90, so that is they must be equal. So negative 15a is equal negative 90. So now you have to divide each side by negative 15, so you will get the value of a, and that is 6. Okay, so this is the value of a. Okay, in the same way you can see we have to equate the coefficient of x. So the coefficient of x on the left side is minus 4a and minus 15b, and here the coefficient of x is 6. Okay, so we have to equate them, that is negative 4a negative 15b is equal 6. So we have to put the value of a here, so that is 6. So 6 times negative 4 is negative 24, and just shift on the other side, so that would become negative 15b is equal 6 and plus 24, so that would become 30. So you will get the value of b here, that is b is equal to negative 2, because there is a negative sign with 15, so this is going to be the value of b, and that is negative 2. Okay, the next is we have to compare the constant term, so that is we have to compare 2a minus 2b minus 15c with negative 209. Okay, so let me do here. So now that is 2a minus 2b minus 15c is equal negative 209. So we have to put the value of a here, so that would become 12, and when we put the value of b here, so that is negative 2 times negative 2 is going to be 4, and then negative 15c is equal minus 209. Okay, so minus 15c is equal, just shift 12 plus 4, that is 16 on the right side of the equation, so that would become negative 209 minus 16, so that would become negative 225. Just divide by c, so you will get the value of c, that is 15. Okay, so we got the value of a, b and c. So just put all these values in the particular solution here. So our particular solution would become, that is y sub p is equal, the value of a, that is 6, so that is going to be 6x squared and plus bx. So b is minus 2, so that would become minus 2x, and then c, the value of c is going to be 15, right? So this is our particular solution. Got it? Now what will be our general solution? So just let me erase. So our general solution is that is y, that is basically the sum of the complementary solution and particular solution. Just putting the values here. So y is equal, what is my complementary solution? That is c1 e raised to the power 5x, then plus c2 e raised to the power minus 3x, and then the particular solution is plus 6x squared minus 2x plus 15. So this is the general solution, right? Now we are going to find the particular solution of the whole second order differential equation with the help of these two conditions. So what are the conditions? That is y at 0 equal 14 and y prime at 0 is equal 25. So first we are going to use this condition. So y, the value of y is 14. Okay, let me say this is our equation 2. So putting x equals 0 and y equal 14 in equation 2. So equation 2 will become, that is y is 14 and x is 0. So it means c1, when we put x equal to 0 in the first term, so e power 0, that is 1, plus c2 e power 0 is again 1, and then when we put in the third term, so this will become 0 and minus 2x would become 0, so we left with 15. So plus 15 here. Just shift this 15 to the left side of the equation, so you will get c1 plus c2 is equal minus 1. Okay, let me call this is an equation number A. Okay, now we are going to use y prime at 0 equal 25. Okay, but we need y prime first. Okay, so we are going to find y prime, that is the derivative of the general solution. So that is going to be y prime is equal, the derivative of the first term, that is c1 e raised to the power 5x. The derivative of e raised to the power 5x is e raised to the power 5x. Again take the derivative of the power, so the derivative of 5x is 5. So the derivative of the first term would become 5 times c1 e raised to the power 5x, and then the second term, that is c2, and the derivative of e raised to the power minus 3x is e raised to the power minus 3x, and just take the derivative of minus 3x, so that would become minus 3. Okay, now plus the derivative of 6 squared is 12x, and the derivative of minus 2x is minus 2, and last the derivative of 15 is 0. Okay, now here we are putting x is 0 and y prime is 25. So that would become, y prime is 25 is equal, so 5 times c1, x is 0, so e power 5 times x, so means e power 0 is 1. So minus 3 c2, again e power minus 0, minus 3 times 0 is 0, so e power 0 is again 1. And here when we put 0, so 12 times 0 is 0, and then last minus 2. Just shift this minus 2 to the other side. So 5c1 minus 3 times c2 is equal 27. So this is, let's say, our equation number B. Okay, so now we are going to solve equation A and B to find the value of C1 and C2. Okay, let me write equation number A like, solve this equation for, let's say, C1. So the value of C1 here, that would become minus 1 minus C2. Okay, so just put this value in equation number B. So here this is equation B. So this implies that 5 times C1 is minus 1 minus C2, then minus 3 times C2 is equal 27. Now simplify the left side of the equation, so that is minus 5 C2 minus 3 C2 is equal to 27. So now minus 5 C2 minus 3 C2 is going to be minus 8 C2, and shift minus 5 to the right side of the equation, so that would become 27 plus 5, so that is 32. So here we get the value of C2, that is minus 4. Okay, now put this value of C2 into equation number A. So equation A will imply that, just let me write here, put in A. Okay, so here C1 and C2 is minus 4, so we will put minus 4 here is equal to minus 1. Just shift minus 4 on the other side, so you will get C1 is equal minus 1 plus 4 is 3. So this is the value of C1. Okay, now putting the values of C1 and C2 into the equation number 2 to get the particular solution. Okay, so here putting C1 is equal 3 and C2 is equal minus 4. So the above equation number 2 will become, that is C1 is 3 e raised to the power 5x, and C2 is minus 4, so that is minus 4 e raised to the power minus 3x, then plus 6x squared, then minus 2x, and then plus 15. Okay, so this is our particular solution. Okay, this is the particular solution of the given second order differential equation.